That's an I. It's an I, but it's okay.
I. Oh. Either way, what all stands for is
Current. Yeah.
they look very similar.
Teachers, this is a reminder of the training in the media center during planning period at this time. Again, test training in the media center at this time for planning period. Thank you.
All right, I'm going to scroll up some. All right, pause your thoughts. Let's just talk about A and B, and then I'm gonna stop. Okay? I saw a couple of us very much on the right track. A couple of us are like way off in left field. Now that's a bad place to be in left field. At least you are still in the field, but we still want to process this in like 5 minutes. So if you have a galvanic cell, that's the key word here, right? What does that have to be? What does that indicate to you? Okay, so this must be a positive E cell upon you doing some sort of math, right? So if that's positive, remember, both reactions are always going to be provided to you as reduction, half reactions. So then you can tell because the electrons are being gained in the reactant side. Remember, electrons in the reactants is reduced. Electrons in the reactants is reduced. So you're like, okay, well, both of them can't be reduced. One must be oxidized. So these values will help you decide who's reduced and who's oxidized. So who's more likely to be reduced according to the values? The bottom one, right? The higher reduction potential, the higher the potential it is to be reduced. Does that make sense? So this is the reduced one, which is at the cathode. This is the oxidized one, which we know this reaction is not rated correctly, but the E cell or the E value is still related to its ability to be reduced. Therefore, we are using that value because that's how I taught you guys to use it. So when you subtract E cell, you do E red, which is the reduced half reaction, minus E ox, which is the oxidation half reaction. But I taught you never to flip the signs because this negative actually is us flipping it. It's just we use the equation instead of doing the flip. So when you actually plug these values in, which is for B, 1.229 volts minus a negative 0.085 volts, this is the reduced half reaction minus the oxidized half reaction. What's the E cell value? 1.314, thanks. So I actually did that part before I did the BCE, because once I figured out who was oxidized and reduced, I basically could figure out A and B together. So knowing who is oxidized and reduced helps you rearrange the equation for A. Which one do I keep? Which half reaction? The bottom one, because it's already written as it should be, to be reduced. So O2 plus 4 H pluses plus 4 electrons yields 2 waters. But this one, I must flip.
So in just flipping that, that's going to show some electrons lost and some electrons gained, which is redox. So we have ethanol plus 3 waters yield 2 CO2s plus 12H plus 12 electrons. So immediately you notice what? Right, so we've got some disproportionate number of electrons. They're not the same number of electrons lost and gained. So to balance this, what do you need to do? Multiply the top one by 3 to create an equal number of electrons, because that's the value of redox. The electrons lost are the electrons gained. So I already know that I'm going to have to distribute this out. So don't cut yourself short. You have time to literally write everything out and make sure you're on the right track. So 3 O2s plus 12 H pluses plus 12 electrons. That's the top, plus C2H5OH plus 3 waters. Those are all the reactants. That's going to yield, keep distributing, 6 H2Os plus 2 carbon dioxides plus 12 H pluses plus 12 electrons. So at least us seeing this, now we understand we can cancel out things on the left and right. So it's going to cancel 12 electrons and 12 H pluses. Yeah, there's 6 waters and 3 waters, right? So totally 3 waters cancel. That leaves us with the leftover 3 here. And then I can just rewrite that balanced equation. So don't remember exactly where the point values fall here, but I'm going to guarantee you it's something to do with balanced and something to do with reactants products in the right place, because you easily could have flipped this reaction, but it would still be balanced, right? It would just be incorrect. So this would give you your points. Get everything down. Oops. Okay. And our E cell value we know is positive. All right, so keep going if you need to finish talking, especially if you're looking at your reference table. That's a good place to start. It's been a while to figure out C. If you forgot the units of amps, you definitely should look at your reference table or someone's reference table. I should be like a one-step problem. You should be done. You should move on to part 2. That one that goes multiple choice on big idea 1. I'm going to finish reading this to the class though. Oh, it's 10. Right there, you're right. Because if you forget what amps are, you don't get your amps. It's current QOT. When I want you to see it's charge per second. Or coulombs per second. It's just good material. Amps is ridiculous. Price of the amp.
Oh, because you go from coulombs to moles of electrons.
All right, come back to me. You should be really close at least. Just need some space.
It sounds like you're on the right track, but I didn't hear
Okay, what were the three givens?
Your
10 milliliters of the sample. What else? Point what? 0.10 amps. Okay, and 20 seconds. 20 with the dot. Was it? Oh, well, the question's up here. I think it was 20 with the dot. Okay, because that's going to help us with sig figs, of course. Okay, so if the question is asking about coulombs, which is charge, some of you guys were like, oh no, I forgot what charge is. I forgot what coulombs is. But if you realize that there's an equation provided to you on your reference table, it's I, which means amps, is equal to Q over T, and then they define each of these. So this is amps is equal to charge, right? Coulombs over time, maybe seconds there, right? Then this helps you see that this is actually a conversion factor. This is 0.10 coulombs per second. Because that's generally how we always rephrase amps to make it look like a conversion factor. So maybe that helps you see that when you have this and this together, what can you do with them? Multiply them, and then seconds will cancel, and you'll get coulombs, which is charge that we're looking for. So I would start off with 20 seconds multiplied by 0.1 coulombs per second, which is just amps. Just rephrased it a little bit here. So how many coulombs? 2.0. If we're going to be, specific to sig figs. So that's a single step question, but you just have to realize what amps were. The next one asks for molarity, right? So remember, part I usually will help you get to part double I, because if not, they wouldn't put those questions kind of together. So do not try to restart the question. A lot of times they really do kick you right back off. So I'm going to start with this value, 2 coulombs, and everybody knows how to cancel coulombs. It's a constant. What constant? Faraday's constant, right? Because I wouldn't want to reuse amps, because then I just get back to time and it's a circle, right? That would be stupid. So then you're going to use Faraday's constant, which is what? 96.485 coulombs per 1 mole of electrons. That's just literally the charge of a mole of electrons. So once we made it to moles of electrons, eventually we want to get to ethanol. So now we have to figure out the relationship between moles of electrons and ethanol. What's the relationship? What is it? Yeah, 1 to 12. So I'm going to scroll way back up here. 12 moles of electrons for every 1 mole of ethanol. So we can't make that up. We do have to pull it from a BCE or from the half reaction there. So 12 moles of electrons and 1 mole of ethanol. And then how do you get to concentration? Divide by liters, right? So moles divided by liters is what concentration is, or molarity. So 1 over the 10 milliliters would not work, so we'd have to convert that milliliters to liters. So 0.010 liters. So 1.74 times 10 to the negative 4th molar. That should be right. We good with that? Okay, so otherwise, if you need lecture help, you got to find that for Q's to work with, okay? Do me a favor, go to multiple choice under Big Idea 1. I think there are 4 or 5 that won't take you very long to do. Oh, how many sig figs did you do? 2. So 1.7, sorry. I wrote 4, but it's 3. 1.7. Just because sig figs. idea one, multiple choice just at the bottom of that big idea little link. The name should be at the top. Today is Wednesday. Once you're done with that multiple choice part, will you pass out these multiple choice tests? We're going to check these in a minute. Who's got a stack? Outbox for me. Okay. Did you already do multiple choice? Just give me one more minute. We're gonna go over it. Put in the outbox screen. Is that
Sure.
Yeah. All right, you got 30 seconds. Finish the last question. All right, come back to me. 3, 2, 1. 18. Shout it out. Let's go. Loud and proud. I heard A and I heard E. All right, so here's the story on this one. Lithium, beryllium, boron, carbon, and nitrogen are all in period 2, right? Lithium, beryllium, boron, carbon, nitrogen, 1, 3. Okay, good. So, what is the direction of the trend for ionization energy? You're doing this, right? Okay, so which hand is ionization energy? Your left hand, so you know that's going to increase up a group and across a period, right? So it can't be lithium because there's no up and down direction here. We're only looking across a period, so it does increase across a period. There are some fluctuations in that. There are some discrepancies in the trend there. And let's just quickly remind ourselves of that. Where does the inflection occur? Okay, so there's something about the end of the orbital being filled. Okay, there's also one more thing. Okay, relates to the word proton. So certainly for the trend to exist, I mean, as the ZEF or nuclear effective charge increases, nitrogen has what? Seven protons versus everybody else who's lower. So this definitely has like the highest protons, highest ZEF. So this is going to create nitrogen to be the correct answer. But just remember, if it did have, like if an oxygen was an example or was an answer choice, most of us would probably choose oxygen because it's even farther, you know, or has more protons. But what happens here is you have like, what is this, 2s2? 2s2, which is lithium beryllium. So they undergo nuclear penetration. So if you were trying to take beryllium's electrons, it'd be very, very, very difficult as lithium-2 because they're so close to the nucleus. Boron, carbon, and nitrogen go to P3, and then you hit 2P4 upon going to oxygen's valence electron shell. So nitrogen technically has one electron in each orbital, right? So that's actually going to have a higher ionization energy out compared to oxygen, because oxygen has an extra electron in one of its electron or one of its p orbitals. So this is nitrogen, this is oxygen. Why does oxygen go down in ionization energy? There's less. No, there's more electron repulsion here with oxygen. I guess it depends on how you phrase it. There's electron repulsion in oxygen. That's less stable. Therefore, it takes less energy to take that electron from oxygen, which is why it goes up, 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 down in oxygen. Okay? So that's just a disclaimer. I really wish they had oxygen on this question. They didn't.
All right, so that was E. 22?
A, you just had to count. And if you can't do a
Subatomics, you can come to tutoring for that one. We're not doing that right now. 23?
What'd you say? E as an elephant?
Yes.
So yeah, you're good. I don't know. I have E circled, but D highlighted for some reason. Oh, maybe because I want to talk about this.
So this is in order. Like basically, an excited state does not go in order of Aufbau's principle. Remember, Aufbau starts off awfully low. There's no skipping of orbitals. This goes from 3s1 to 3p1, so there's a jump in the energy from the single s electron that should have been 3s2. Last one?
A, atomic radius. What's the trend? What's the trend? Okay, there's really not any exceptions to that. Really? So as you have more orbitals, you get bigger. As you have less protons, you get bigger.
Okay. Let's take a break from Big Idea 1 for a second. I know we just got started, but let's check over those 2017 English race. You guys have a highlighter or something to write with? Yeah. That's only if you're providing data, like true numbers. But all of these are in the second and third period. Right? So their valence electrons are what a group number is. So you can't compare that question to this question. Because that question's about one single atom and all of their ionization energies. Their first ionization energy. These are for the first ionization energy for 5 protons. So those are 2 totals. Do me a favor, Taz and Nina's grade, those 2 that are in there, Joy and Joy. All right, let's go. I promise I have this room ready for you. That's not it. All right, I'm going to call these out. They're in the out box. Out box. The middle box. You've been in here for a year. I'm just going to let you guys look for a second while they get their lives together. It's good. It's good. I'm just going to be quiet once you guys look because some of you are listening. Thank you guys. Yeah. I'm going. I'm waiting on my slow folks. So I'm gonna scroll down just a little bit. I'm scrolling down to 25. Don't kill me. Oh my goodness. Okay, there we go.
If you guessed and you got it right, that's not something to be proud of. That is something that we should work on. That is not the skill that we were testing. I will scroll right back up in a second, start from the bottom and work backwards.
I probably said terrible, but this is way better than I usually do.
Scroll back up a little bit.
Just gonna scroll back up. I know, because we had people looking for.
You know the drill. After you finish, please put out a 50 at the top. I hope that this has been improving over the past 3 tests. I mean, and you've seen like some of these questions. Not maybe that helped, maybe it didn't. The ones you've seen 3 times, I hope you got right. Don't read it. I'm just gonna leave it there, so you're fine. Yeah, I know you're working on it too. I appreciate it. I'm just leaving it there. I'm just gonna scroll down whenever you guys are ready. There's 2 to go seats right here, but that's easier for you to see and your ladies. Upon you finishing, you should start communicating with your colleagues. I will direct you, we're going to probably do this for 15 minutes, look over multiple choice. I'll direct you that I have to do my work here and here, and you can sit at a lab station and look at my work for questions, and then come around and talk to you as well. But I've been making some problems in my work meeting for a long
Yeah, 42 is D. I can go all the way down. Yeah. I will go. I'm sorry if I'm screwing somebody up, but there you go.
Hold on.
This 4 is coming soon.
You're talking it out. If you want to see my work, or Jason's standing up. All my work.
And we have slightly higher. The only thing we get to so like they collect let's say 100 and this how many of the
And you guys can spread out. Like, I mean, I have 2 copies of my work, so some of you guys can spread out into 2 copies. I have my work, but I don't know
I have a question
about number 8. And I think that was the best.
So I did it by adding up all of the volumes.
Okay, so you guys first you get a total volume of what, 20 you're now creating just divided by. So he was adding between that he had a total pressure or total volume of total volume of 20 that 100 years. And then we had a new volume
I did it and I didn't know I did it. Like I just don't. Okay.
Sometimes it's nice to say like, yeah, I can actually understand that it's a long difference. It's a 1-to-1 wall ratio.
I am not rushing you at all, but listen to me. I'm trying to pass all the career responses, and I put all my answer keys for career responses back in like 20, I have like 12 copies. We can share that copy, right? Like, do not rush yourself to multiple choice. That's what you get bang for your buck. Really, if you don't give up multiple choice, give up on career response. I'm just joking. No, I'm a second.
It's obviously not
Okay, so why is it that you have the lower
you go you can mold the mold are just the internal I didn't try that as one more. I just put that and then see more.
Yeah, and N is the multiple electrons, so it would be 6. Fairness constant, and then wait, what if you use 6 multiple electrons
okay, I gather some deep because it's the same. It has to be the basis of periodic theories are based on information. Like, so lead is only going to be shown in that group.
They'll never ask what's that like they might ask for what's electric affairs.
Yeah, I can.
I mean, so they're not going to.
I just remember
All right, so it's a 4-point question. You should want to
but then the sample is 75%. So the sample,
You guys can move from that table.
the sample has something that has more chlorine to make a ton of sense. Especially increase in So whatever we're looking for, whatever we're putting on here has more chlorine than whatever we're looking for. And then because you look at the molar mass, so LICL is 735, so that's the molar mass. So most of it is chlorine. It's 5 times bigger.
It's because I multiplied by 1.5.
ACL is 39. 39. So that's really So imagine this is basically and you all have spikes that are showing stronger ones are running after so because of the conditions. So this is number of electrons. What is the height number of electrons? So you know it doesn't happen spontaneously. And the thing is, so that'd be like the 1s2 data 1
After
yeah, 21. That's just great like water flow. I don't know, it's like look at the metrics. But like there is study that's more. No matter how like that means it's non-polar. Polar things are not and then that is between NH3 and CH3 and HCl. You can see. I saw her last time. Like on it's like I just really I got like plus 3 from it and it's minus 3. It's like I think that makes sense. Okay, so it's like it says it takes 3 so is it just because like you multiply the grams by 2, then you move the just there's a 3 change. So you have you have all I need to for the PF and then we add 4 and that's your 2 like I just said, oh my, I circled it because like I didn't. I got 40. I did the opposite. So,
Yeah, 67. So you drew more than a 5 than I got at this point. Three more. Yeah. Well, I was on like the grade
because I got thrown off by having so and I was like, what is
Oh, that was like,
I didn't even know, but I mean, I like really actually never did this.
I killed it. Something with first. I looked and I said, oh, let's go ahead and buy. I was like, A or B.
I actually tried. Oh, that makes sense. Because, okay, so
It's aspect the oval fun with the so I
they're adding like when you have the situations and stuff, and then just add yeah, because anyway, she's not really react to it. It's a decrease.
Okay, as long as you can figure out real stuff, if you figure out you will be because that's what calculus is driven this one? Oh, I would recommend you do a lot of content. I got yeah, I thought of that. Well, she has a science.
It's saying that if you're taking the molecules and then you break them apart, putting them together,
I don't remember because we were in Brazil. We sat next to
break this apart.
no, we I announced we went to I saw it in like in my last break apart. You know how hey,
Is it like, right, like, because breaking bonds is always.
Yeah, that's.
Yeah.
Alright, you cannot lose over free response, you need to make sure you do that in the next couple minutes. There are multiple AP exam rubrics, which some of them are a little bit vague, but you can read them out on it, and my works are there as well. You can read them
Yeah, you should, basically, no mistake, didn't make oh yeah, right now, not taking on, but you think that's fine.
Oh, this makes sense, I'm in a word. And also two.
Oh, you like that?
There should be 5 H2O2 blood.
Yeah, in the left side.
Oh, I think I just did
Well, you're not going to get zero. You can always get 85 as long as you don't get zero. I'm going to get zero there. Because I know it's not going to get zero. You're guaranteed to get about 50. So no matter what you do, you will get if you use the actual you will get okay, so are we going to ask about not here? Yeah. Some things I'm not doing any math. It's like that's why I thought it's like I'm not doing any math. I'm really trying to figure out what I can do. And that's why the time for 6% today
K is large.
This one is like
I mean, if they didn't have a gas on there that wasn't like gas, I was like,
we're gonna start the ionization.
okay, that was like, alright,
Are you gonna do it automatically?
I didn't know you know. I didn't know you know. So let's use some scale. In the middle, some S. Yeah, so it's like, alright, so the problem at the bottom is scales in the middle. So that one gives PCL.
All right, listen up here. Just pause your conversations in 5, 4, 3, 2.
One. Let me talk at you for a minute, okay? So eyes up for a moment. On the ozone question, first of all, I like that we did ozone like 2 days ago. Remember drawing the resonance structure? I did that on purpose so you could have at least a general understanding of resonance. But on the question that talked about, hold up. Consider, okay, so first off, if it's first order, they love to do first order a lot because they give you the reference table, which has the first order half reaction or half-life equation and the integrated rate law. So don't neglect to use your reference table like it's there for you, okay? And considering the data provided, they told you the K1, they told you rate is equal to K1 times concentration of ozone. We only did this once, and it was on a crystal violet lab where you had the bright purple stuff, and we tracked the concentration over time using the Spec 20s, or the colorimeters. If you have another reactant and it's flooded the system, meaning it's in higher concentration, and we can't track that data because like it's clear, for example, or it's just not very trackable, you have to incorporate that into the K value. So when they say rate is equal to K1 times ozone, K1 has incorporated the other reactant's concentration to whatever order it is. So that's why they modified and they changed, to see if you knew that, down here for part 3. Briefly explain why the data in the graph are also consistent with the following rate data here. So K1 is actually equal to what? Relating this to what they've written in part 3. K2 times bisulfite concentration. So that's why they excluded it from the first rate law, because the first rate law, you only had data to support ozone, so you only can make conclusions about ozone. But they're trying to tell you that the other reactant is, it has to have an order of some sort. So you basically had mentioned that was flooded the system, so the concentration stayed essentially the same, and we can contain that in the K value itself that was published on part 1. And then this question down here, I think you'll get a credit, unless you're just totally way off, I think you should get credit for what you put, as long as you're mentioning rate calculation data or rate data and concentration data. I don't think there's much other data you could really put in there to get this kind of law, okay? So if you need to keep looking at what you're looking at, you can. There's some resources on my website. If you need me, I'll be around. And if you're just like, heck yeah, I want to do a 2014 practice exam, I have, we're not going to get to this in class, so I have a bunch of copies.
Can we take this home?
You cannot take this home right now, but sorry, my secure copies, I'm trying to stay licensed here. But you feel free, you have about 25 minutes. You can work on this now, it's just multiple choice, okay? And I have the answer key right here when you're ready. I'll be right there. Same number, it's a whole practice exam. So feel free to get through as much as you can, and then you can check your flooding just means that you have a high concentration of one reactant, that was particular, versus that reactant which they actually tried. So when this is flooded, this is a super excess and this is the limiting. And so the limiting one, controls the reaction because you just don't have enough of it. So it's going to slow the process down as it flows. So since that concentration is essentially not changing too much, here's that one. We ignore that concentration. True rate constant. Okay, whatever is reacting with it doesn't change much because there's so much.
This changes a lot, because this is like,
Right.
this doesn't change, because it's a super excess. So it might change by like 1%. Instead of trying to concentrate on it's just changing, they basically compile that information and they call it a new K value, and that's our rate constant for you. Yes, ma'am. Sorry, I was trying to
Yeah.
One second. Make sure that you put your multiple choice and free response scores on there. I don't have time to count after you. And you can put those back in the box when you're ready.
Oh my God.
You're-
You know what I'm saying? They want to do it because they can't until you prove it. I know, they don't want to, it's a 4-point question. But you know that 2.2. And you were like, oh, if you, that's what I mean, like, you wish you can't take it home, but you guys can get that your example tomorrow.
Yep. Make sure you have your scores on there, okay?
Yeah, I got 34.
34 out of the multiple choice. What'd you get on multiple choice? Did you recognize some common things you're doing? Like, you just sit down and talk to me. I know you're talking to your right. Sit down and talk to me sometime. Because you can do more than that. Yeah.
For the presentation.
Yeah.
Can you just, because I have mass spec, like, models.
Okay.
For your